Good morning, everybody. Okay, so it's just 10 o'clock. We'll give people another minute before we kick off. Ewan Canavan is my name. I'm a portfolio manager in IDD, for those of you that don't know me. And this morning's webinar is about lifting operations on our sites. So we'll just give it one more minute there just for people to come in, okay?
Just a quick test. Brian, would you be able to just take your mic off?
Yeah, just off there now, Lisa.
Perfect. That's great. Thanks a million. That's fine.
Okay. We'll go ahead. So look, just to note, I suppose the call is being recorded. And if anybody has any questions, if you can just put them into the Q&A function and we'll get to them afterwards. So as I said there, this morning's webinar is going to focus on lifting operations, and it's one of Ishkieran's critical risks. And it's a focus, I suppose, following some serious incidents on some of our sites in IDD. And pretty much every day on every one of our sites in IDD, lifting operations are carried out. And that can range from the very small sites to the very large ones. And sometimes we kind of focus lifting operations and lifting plans on the larger side of things. But, you know, a lot of our crews are out there lifting a simple thing like a pipe, a water pipe, a sewer pipe, small fittings, and it all needs to be planned. And it's really important that we learn from the incidents that have happened. And it's important that everyone involved in lifting operations on our sites is aware of our procedures and our requirements. And ultimately, it's about getting people home safely in the evening. So they come to work and they go home safely. And that's what this is all about. So it's about raising awareness and improving safety on our sites. So we have a safety moment video now that we're going to show you. It's about correct and incorrect slinging of lifts. And just to note, this is created in collaboration with Ishkieran, ASM, Proactive Safety, the Murphy Group, and O'Brien Frainhart. So if you want to play it there, Rahul, please. Okay, so I think that's a really good safety video there, and it's an example of the safety videos that I suppose we're asking people to upload onto the MiSafe website. That particular video and 2 more will be uploaded in April. So the website is uploaded, or the videos are uploaded each month at the start of each month. And we'd ask people to, I suppose, think about examples on their site that they can use, that they might be able to do a little video of. It's about sharing lessons learned, good catches, conversation starters to influence each other and the industry. And I suppose just go and check them out on the MiSafe website if you haven't done so already, and you can use them for safety moments. There's really good stuff there. So with that, I'm just going to introduce our first speaker. It's Michael Norton from Proactive Safety, and he's going to cover roles and responsibilities and lift plans, both crane and non-crane. So over to you, Michael. Thanks.
Good morning to you all. I've been involved in the lifting industry for the last 30+ years, starting off as a young crane operator with McAlpine in London, coming back to Ireland back in '96, and subsequently qualifying as a safety advisor in 2000 and 2003, started off my own business. And ever since, all the ways through, the lifting industry has been part and parcel of the Proactive brand. And people who would know me know that I travel the length and breadth of the countryside looking at lifting operations, training slingers, training operators, putting plans together, APs, lifting supervisors. And there are so many questions out there at this stage in respect of the roles, responsibilities, when we need plans, the risks, the hazards, all these elements. And as a consultant and trainer, you're trying to get as much information out as I possibly can to the companies I go and advise and talk to. So I'm going to try and get as much as I can with yourselves over the next couple of hours, or the next couple of minutes. The importance of lift planning, the plan is there, and there are so many misconceptions. When do I need a plan? When do I not need a plan? When is it required, and what should be inside the plan? The roles and responsibilities, who initially takes responsibility of the lift? Regardless of what we're lifting, what machine is there, what's doing it, who takes responsibility when it comes into play? And compliance with the requirements. Our general applications are there, the construction regulations are there, but we also have 2 major codes of practice that have come in over the last couple of years. IS 360 2019 and IS 361 2024. And these are 2 guidance documents that carry special weight. We know that when it comes to accident incidents and the information that's there and how this information is being implemented on projects across the country itself. So this is a breakdown of the accidents that I've investigated. You can imagine now, in some 23, 24 years as a consultant and trainer, you get to see your fair share of accidents. And we look at that big dramatic element of the crane coming over, the tower crane coming down, or the self crane, whatever it is, you know, and you get to see it across social media. But a lot of the incidents that I'm dealing with, and a lot of the near misses, and the lack of information I come across, is the small stuff. It's the small stuff we're dealing with, the chains, the slings, the shackles, and the training that we're giving the teams out there. And about 44% of the accidents that I deal with, the incidents, our loads are actually falling from appliances lifted, where they actually come off during the lifting operation, be it from, you know, poor slinging, overloading slinging, load slipping, all these elements here. Falls from heights where guys are getting up and trying to sling the load itself and will fall from what they're on. Faulty equipment. It's a very easy target for a consultant like myself to go in and look at the lifting operation where we're looking at slings, how they're being stored, how they're being looked at. All that factors there. And we come across a lot of faulty equipment. And I'm surprised because we go into some locations and you expect a very high standard, and subsequently it's not there. It's not there. And the problem we have is that the team may not know what they're doing wrong when it comes to the equipment itself, how it's being used, how it's being stored. 11% are struck by loads themselves. And we look at a mobile crane, for instance, a mobile crane that comes onto site, when we look at the accidents over the years, about 25% of mobile crane accidents are where guys or personnel actually get crushed with the load. And that boom deflection kicks into play. And you ask team, what's boom deflection? And they don't realize it, but yet quarter of our accidents are happening where a load is swinging or being crushed. Cranes coming in contact with other cranes, plant and machinery, and 6% of accidents that have investigated over the years where the machine actually overturned during the lifting operation, through overloading, through shock loads, through poor ground conditions. And subsequently, most of my incidents are coming from this area, the lifting gear itself, and our 44% of accidents are coming off through these elements here. And later on, I'm just going to do a quick briefing on slings and chains, but really and truly, to show you from the slings, from the chains we're using, from endless slings, from accessories such as chain blocks and lever hoists and all these elements here. And a lot of people don't realize when you put a chain block onto a lifting appliance or a lever hoist, you downgrade its capacity by 15%. As you see in the video there earlier on, when you choke a piece of lifting gear, you lose 20% of its capacity. But people don't realize the same thing happens with a wire rope with a chain. When you introduce that angle, you reduce the capacity. And subsequently, these are some of the accidents that have occurred over the years, you know, that we've been involved in, or incidents that have come into us where slings involved, 2-3 ton slings involved there. You can see it on the left-hand side, and they knotted together. Where slings are twisted and knotted, they lose 2/3 of their lifting capacity. When we come to a set of chains and we look at the chains, and our slingers, you know, do they actually know what they're looking at when it comes to inspecting the lifting gear? Because 10% of wear along the link of the chain takes that chain out of commission. Most of the chains we're using on site are 10 millimeters. That's 1 millimeter wear on any link of a chain taken out of commission. Look at the center one there where the stretch has come into play with the hook itself. And the hook, when you lift in the point of a hook, it's only good for 40% of its capacity. But yet our slinger may not know that you can only put one piece of lifting gear on a hook at any one time. The use of packing. Slings during lifting operations stretch. And they stretch, the bigger the sling, the more it's going to stretch. And it's rubbing off that sharp edge. And if you look at your operations today, and if you are actually lifting on site today, regardless, have a look and see how the sling is coming in contact with the surface of the load that you're actually lifting, surface load that you're lifting, and how it's not being protected. And through the stretching on the sling and the abrasive nature of the load at that sharp edge, that it's cutting into the load itself. Or where we come across the wire loop lifting knives, where they actually, you know, they're being thrown from height. And this is what happened, that one there was actually thrown from a height, hit the ground, shock loading, causing hairline cracks. When we see lifting gear being dragged along the ground, not being looked after, left out, exposed to the elements, all these factors are all leading to the problems that we're dealing with when it comes to lifting gear failure, how we're storing it, how we're looking after it. Subsequently, this is a breakdown of the accidents with slings that we've dealt with. About 81% of the accidents that I deal with over the years have been with slings. We've lost the knowledge of chains. It's a big, big problem because we're now using slings an awful lot more to lift loads. And subsequently, the sling might not have been designed for that particular product to lift, and it's causing problems. So 59% of our accidents are happening with flat web slings. About 22% are occurring with your rounded sling. The rounded sling itself, or that endless sling. 12% are happening with wire ropes, and about 7% with chains and chainslings. And every audit I go on to, guaranteed I'll walk the floor, walk the site, walk the location, and I'm going to find slings that have failed because of damage or chains with issues with them. We look at how they're being stored, how they're being looked at. All these elements are all leading to the problems we're dealing with. And this is not just a discussion on today. This is an industry problem that I'm dealing with. And anyone that knows me knows the Jeep gets filled up on a Sunday evening and gone all week across the country, training, auditing, inspection, or developing policies and procedures for lifting. All these elements come into play. What are management required to do? Under IS 360, our code of practice, under our construction regulations, under our general applications, under the Safety, Health and Welfare Work Act, it's all there for us. It's clearly defined. We have to plan our lifting operations. And that's looking at the appointment of your team. Are they competent? Are they able to do the job they're supposed to? Are they trained? Have they enough knowledge? Or are they actually guessing when it comes to putting a sling on the load? The resources are available there that they can understand, and the training is available out there across the industry. Yes, we have issues there, but there is a multitude of different courses that are available for slingers, advanced slinger signal or lifting supervisor, appointed person, even lifting with suspended loads, 360 excavators, rubber ducks, telescopic handlers, using appliances for lifting, but are the team actually trained? Effective communication, that we're actually developing lift plans for operations. And we can look at the mobile crane coming through and your tower crane and contract lifting and crane hire, and that's a discussion for another day. But the reality is the communication process that's happening. Aren't the lads aware of what they're supposed to do when it comes to the lifting operation? And then monitoring operations. And I'm always telling sites when I go out to them or locations, where's your quarantine area for lifting gear? Where are you keeping the lifting gear that's being damaged? Well, we don't, we cut it up and throw it in the skip. But that's not really giving you a clear reflection on exactly how your lifting gear is being damaged, why is it being damaged, what's it coming in contact with? Because if you're going through a multitude of 3-ton slings, 2-ton or 1-ton, or a lot of chains, you kind of want to be looking at why they're being damaged, rather than the application that's causing the damage. And maybe a simple tweak by changing a piece of lifting gear can eliminate the problem. If you look at the lift plans that have been put together, these fantastic documents that come in, you look at them and you go through them, you sign them off. But how many times do you actually go down the site and look to see, is the appliance actually lifting what it's supposed to lift? Is it doing what it's supposed to do in compliance with the plan itself? All lifting operations. Now, you know, one of the most common questions I get asked, do I need a lifting plan for an excavator? Do I need it for a rubber duck? Do I need it for a high end? The answer is yes. If you're lifting, you need a plan. The information has to be there, that lads can look at the information, that they know exactly. You put a sling on the load, this is what's going to happen. You put a chain on, this is the signals you're supposed to use. This is the process of what you're going to do. The plan has to be there. If it's suspended, it needs a plan. That's the best advice I can give anyone there. If it's hanging from a hook, you need a plan with it. Where is it coming from? I mean, the legislation is there. Section 43 of the general application clearly tells us that all lifting operations must be properly planned, appropriately supervised, and carried out to protect the safety of all employees. Regardless, it doesn't say a crane, it doesn't identify any appliance, it says all lifting operations, planned, supervised, and carried out to protect the safety of all employees. The importance of that lift plan, it reduces the risks, accidents, injuries, and equipment failure. If the information is there, the team know what they're looking at. Clear direction for those involved. It takes out the guessing game. When I do a presentation, especially the advanced slinger program, I write up on the top of the board, guessing, write in red lighting. And I say to the guys every time, most of the information you're going to be coming back to me, will you be guessing? And sure enough, you ask the question, are you guessing that? Yes, I am. We don't always have that information. Clear direction for us meets the industry requirements, as I said. The general applications are there. It organizes personnel. It gives personnel direction as to what is required. You'll need a shackle, a set of chains, and 2 slings to lift that load. It eliminates guessing from the team. Once the team know what's required and they follow the plan, it's there clear. It doesn't have to be a big detailed document. Once they understand the contents of it, then you're okay. Obviously, it prevents damage to equipment, to structures, and injury to personnel. Go back to slide number 2. 44% of accidents happen when load actually comes off the appliance lifting it. This is your team. When it comes to lifting, you have to have a competent person in place. Who is that competent person? The appointed person obviously puts the plan together. Does he need to be on site at all times? No, he does not, or she does not. However, they have to be there should the risk required. If you're going into that complex lifting, the AP must be present. Our lifting supervisor has to be there. You know, we're doing a lifting operation later on tonight in Cork. The question was said to me, the slinger will be the lifting supervisor. No, he won't. The slinger is a slinger. Lifting supervisor oversees the operation. They implement the plan. Your machine driver, your crane operator, and your slinger signaler. And the slinger signaler is the key to the operation. They are the ones that are like the front of the orchestra. They coordinate the whole lot. However, sometimes they're the one with the least amount of training. And that's the worrying element of it. The slinger signaler directs every element of it. The appointed person is there and is the most senior element when it comes to lifting operations. They develop the plan in reflection of the machine that you're using, the crane you're using. They look at the lifting gear being used. They look at the slinging process. They look at how the mode factors are going to come into gear, how we're going to downgrade the lifting gear, how it goes on. The plan also defines the roles, who is doing what. And it is so important that when that plan is developed, that personnel sign on to acceptance of the role itself. The plan itself will also look at the risks associated with the operation. And the risk assessment should reflect exactly what we're doing, not a generic document that's copy and pasted, that the risk assessment reflects every element of it. And ensures that personnel are competent for the task itself. As I said to you on the previous slide, our slingers, we're not giving our slingers enough training. We know that it's a problem in the industry itself. When I first started training back in 2001, as one of the first CSAS trainers to go through the program, slinger signaling was a 3-day course. Today it's a 1-day assessment course. So it's something that you need to look at when it comes to personnel. Are they competent? Are they trained? Are they aware of their roles and responsibilities? Or are they guessing? The crane operator, sorry, I missed one there. The lifting supervisor. The lifting supervisor obviously is there on site. They attend the training program that gives them the knowledge and experience to implement that lift plan. As I said, the AP does not need to be on site unless it's a complex lift or the risk assessment deems it, but that lifting supervisor should be there. They're directing and putting in place the contents of the plan. They're making sure that everything is correct in respect of the machine, the equipment, the lifting gear, the personnel. They coordinate your team. They implement your safety procedures in respect of lifting, and they can deal with any issues that may arise in respect of the lifting operation. They cannot change a plan. They can contact the AP because the AP is the only one that never change a plan. But in reality, that lifting supervisor is the eyes and ears of the lifting operation and the appointed person. They communicate clearly with the AP itself, and they ensure that lifting operations are followed and the plan is implemented correctly. And at any stage, if they deem it unsafe, they stop. They stand back from it, and they assess it and decide on the best course of action. Crane operator, machine operator. If you look closely at the picture, that's my 23-year-old daughter. She's a crane operator at the moment, slinger signaler, and absolutely loves it, loves the industry. And it's great to see more and more women coming into the industry as crane operators and slingers. The crane operator will operate and control the crane in compliance with manufacturer's instructions. They comply with the lifting supervisor and the slinger. They ensure the crane is operated safely and it operates to its limits and in accordance with the lift plan. And obviously they look at any mechanical issues or unsafe conditions. And we can apply that to the machine operator, to the rubber duck, JCB, excavator, that they understand the limitations of their machines and they understand the dangers associated with overloading that machine by going too far beyond the lifting capacity of the machine itself. And we see where the accidents and incidents occur where that lifting operation fails as a result. The slinger, the one person that doesn't get enough training. I've said it for years, I've been beating the drum for years. They attach that load, they secure the load itself, they put the lifting gear onto the load and they apply that correct downgrading, that mode factor, that angle of lift. All of those factors come into place. They also ensure that that load is safe when it's slow. They coordinate and implement that exclusion zone, that when we do actually lift the load and it's lifted level, it's lifted safe, and that the load itself is secure before they send it up. Because at the end of the day, we are defeating gravity. When you attach that load onto that appliance, you're defeating gravity. You are sending that load up to the location it's going to. There's always going to be risk. We can't fully eliminate the risk, but we can implement enough control measures to control it, to put in place and reduce the likelihood of incidents and accidents happening. They are the eyes and ears, obviously, of that crane operator or the slinger, when the machine operator, when they're directing the operation, when they're lifting the load, when they're making sure everything's all right. And also, they check the gear. They store away the gear. And if you ask your slingers, when you go back onto site later on this morning, do you know how to check a sling? Do you know how to check a chains? Has anyone ever showed you? And you'll be surprised the answer will come back. If you go and ask them today, what happens when you choke a piece of lifting gear? Or what is mode factor? Or how often is lifting gear certified? Again, you may be surprised with the answers you get back. Because a lot of the time, the guys may not have the information that they need to know. Lifting operations, as I said, are inherently dangerous. You know, we're dealing with it, and you put a search into social media for crane accidents there, for lifting accidents, and you're going to get to see these big dramatic events where mobile cranes and towers are overturning, where self-erectors are coming down. And we see it across social media. But how many people are looking at that small stuff, where the sling is lifted with an excavator, the excavator is trying to get the load out, or lifting trench posts, or chains on the wrong way and they're being shock loaded and stressed, or where we're actually tracking and moving loads and that vibration is coming into play. How shackles on excavators, one of the most common pieces of lifting gear I come across there with excavators, shackle attached onto the quick hitch, and that quick hitch is bending the shackle because it can't get enough height to get the load up high enough out of the excavation. These factors here, where chains are twisted and turned and O-rings are twisted and turned, there are risks that can be put in play, but are seldom eliminated. Remember this much, your CSCS carded operator has a CSCS card for operating an excavator to open excavations and to backfill them again. He doesn't get any training on lifting operations. One slide, that's it. When it comes to the ground worker, you know, are they trained, are they competent to work with that excavator to lift that load? The mobile crane operator, the tower crane, the high-up operator, all these factors here come into play. And it's only when the accident happens that the procedures are not in place and the training is not there. As I said to you previously, controls are put in place, but are not always being followed. Many times when you look at that lift plan, like I said, Do you go down and look at the location? Do you check to see exactly how the appliance is set up? Do you check to see what radius is at, what is lifting at, and so on? Conclusion. The team itself, look at your team. Are they trained? Are they competent? Are they aware of their roles and responsibilities? Do they know exactly what they're supposed to do when it comes to lifting? Have you got the lift plan in place? Is the lift plan representing what you're doing? Is it relevant to the operation? Is it effective? And does it comply with the safe lifting standards? Have a look at the storage of your lifting gear. Where is it being kept? How is it being maintained? Is it safe? Have a look at your quarantine. What's being damaged? How it's being damaged? And so on. Thank you very much.
Okay, thanks very much, Michael. A huge amount of information there, really good stuff. And I think the key message from that for me anyway was, if it's suspended, you need a plan. It doesn't matter how small, you need a plan and need to have the right procedures and the right trained people in place. Thanks very much, Michael. Okay, so we're just going to bring in our second speaker, Brian Murray from the Murphy Group, and he's going to speak about an initiative that the Murphy Group are running, where all of their excavator drivers are being sent on an excavator as a crane course to ensure competence for all of their drivers. Over to you, Brian. Thanks.
Okay, thanks, Ewan. Hi, everyone. My name is Brian Murray. I've been part of the safety team at Murphy for the last 11 years, so I've seen plenty of lifting. So look, Murphy carry out lifting on a daily basis. We lift a whole range of stuff every day out on site: steel pipework, T-pieces, valve arrangements, concrete pipes, trench boxes, temporary works, small plant and equipment, generators, compressors. So a wide variety of stuff we're lifting there daily on our sites. We have our own fleet of 72 excavators at the moment. They're ranging from 8 ton to 36 ton. We have 5 ton down as well. So why do we bring in this initiative? Look, we did find there were some gaps in our operator competency there, through inspections, through audits, through driver feedback as well, and through instant investigations. We found those gaps there. So look, the main ones there were understanding of lift plans. The drivers, the 360 drivers knew the lift plans were there, but the detail in those lift plans there. Details around pick and carry when you're lifting trench boxes, things like that across the site, uneven ground. The detail in that, a little bit on hitch tilt there as well. You see in the photograph there on the right, where the hitch is too far back and it's putting pressure on the O-ring, which could cause a failure or damage. Alarm limitations and overrides. You know, if those alarms are going off, why they're going off. You know, there's a reason for that. Around the rated capacity indicator as well that we have on board our machines there, just general knowledge. You know, the driver sees the RCI on board. We use Prolex systems, but not fully aware of the function of it there. Duty charts as well. You know, when you lift over the side, you're lifting with the blade up, you're reducing your capacity, the center of gravity loads, and below ground reach as well when you're lifting into excavations, trench boxes, concrete pipes, and just control measures around the interaction and the communication with the slingers as well. They have a key role, but it's just that communication between those. Yeah. So we look at the current Solis CS 360 operator assessment. As Michael was saying, it's a one-day assessment. You know, it's probably not enough to cover lifting, but at the moment it just focuses on pre-start checks, traveling, and digging and loading with the bucket. Basically, it doesn't cover very much in terms of lifting. So looking at industry instance and across the Murphy Group as well, through our investigations, we've found uncontrolled load shift, center of gravity not assessed, the position of the slinger between the load being lifted and other site materials, and obstructions there. The slinger is putting him or herself in that line of fire. Accidental movement to the controls as well, the dead man not engaged. You know, we look at excavators, they're designed for moving earth as efficiently as possible. The controls are you know, designed to move the boom and the dipper quickly, whereas the crane, it's a lot more slower, a lot more controlled. Okay. So yeah, look, the solution we came up with was obviously to give our excavator operators a bit more training on that. So we went down the route of the MPOR's excavator as crane training for our CSCS 360 operators. So we also added on some extra training there on lift plans, lift plan awareness, getting into the detail of lift plan, not just having it in the machine and not knowing about it. You know, going down to the detail, the load charts and all that. We have Prolex installed on all our machines as well. So the rated capacity indicators have height and slew restriction as well. So we give the drivers training on that as well. And we also have our Murphy essential standards for lifting as well. It's a small waterproof booklet there. We put in we give all the excavator drivers as well and brief them on that. Okay. That's just a brief rundown of what's included in the MPOR's practical tests. So traveling to the work area, preparing and setting up the lift, liaison with the slinger signaler as well. I said that's quite key. Carrying out lifting and traveling duties as well, the lift and the pick and the shutdown procedures as well. So that's the practical element. So it's a mixture of theory and practical at the training centre. So yep, that's it for me. Thank you.
Thanks very much, Brian. Sorry. That's a really good initiative by the Murphy Group. I think, you know, identifying that gap in the existing training and really leading by example there. So well done and thanks, Brian. I'm just going to bring back in Michael Norton again. He's going to talk through some lifting equipment and rigging. And I think we probably have about 8 or 9 minutes, I'd say there now. Michael, thanks.
Okay. I hope you can all see me there. I suppose it's important there that you understand the dangers associated with the lifting gear. And I showed you a breakdown earlier on. But when you're inspecting lifting gear, we'll use a 2-ton sling, for example. First source of information, obviously, is the tag. If you can't read the information on the tag, you know, you don't get a clear reflection of the limitations of that piece of lifting gear. The tag itself has 5 vital pieces of information. From its working load limit, from its serial number, from its date of manufacture, from the length of the sling and the configurations. And the sling itself is designed in such a way, obviously, to give you its best lifting capabilities in that configuration in a straight line. However, when you choke that sling, its capacity is drastically reduced. You're down to 1.6 ton in a choke because obviously you lose 20% of its capacity. But to go back to the inspection process, the tag is not there. All that information is relevant on it. You can see the drawings that are there. You probably can't, but anyway, you can see the drawings that are there, the configurations of the sling itself. But when we're inspecting our sling, the first thing you're looking at is the eye of the sling. And over the years, you may have seen the eye of the sling go onto the fork of a telescopic handle or a fork, which is totally wrong. All right, you can never lift on one fork arm. Number 2, the sharp edges are cutting the sling because the eye of the sling is cutting against the blade of the forks. And number 3, you never open the eye of the sling any more than 20 degrees itself. As we're going down along, you're checking for cuts, rips, tears, and contamination along the sling itself. You'll notice that the sling itself, you know, any contamination with oil, grease, anything of this nature will take it out of service. Subsequently, when you get to the other end, open the eye itself, make sure it's okay, check that the stitching is all right, and back down the far side. Again, it takes, you know, half a minute to check the sling itself. When the sling goes on to a hook, regardless of what it is, the tag always goes on the hook. The tag itself passes through the eye, and subsequently, where the fold of the sling is, where the wider part of the sling is, you never go above that point. That's your highest point when it comes to sling. So if you find damage up against that part of the sling, where it is fraying or damaging, lads are using slings that are too short for the operation. They're too short for it, all right? So be conscious of that side. Choking it, as I said, 20% loss. Basket configuration, that's if there's capacity is doubled. And the cradle, when we put the 2 eyes onto the shackle onto the hook, like so, it reduces capacity down to 2.8 tons, 2.8 tons. And always remember with a mold factor in slings, subsequently 2 slings will only lift 2.8 tons up to an angle of 90 degrees. When it comes to a set of chains, the most vital piece of information on the set of chains is the sheriff's badge, that badge there. And it has a multitude of information on it, from the working load limit up to 90 degrees and then up to 120 degrees, the serial number, the grade, the link size, and the length of the slings themselves. And all that information is there for us. And when we're checking our O-ring to make sure it's okay, from the hammer locks to the swan neck shortening clutches to the coupling link. And all the ways down along, you're checking chains to make sure they're not bent, they're not twisted, they're not kinked, and they're not out of shape in any way. When you get to the hook element of it, it's known as the clevis hook. This is your shank, back, base, and face. And when we open the hook itself, it should open and close correctly. Remember, you can't have any more than 3 millimeter wear from the underside of the safety catch to the top of the hook itself. Inside here is the saddle. Inside the saddle of the hook itself. And manufacturers tell you can only have one piece of lifting gear side in the saddle. If you're using more than one, you would use a shackle. And the shackle pin must always sit in the saddle of the hook unless it is going directly into the lifting line. There's a small pointer you can show lads later on. When you look at the sheriff's badge on the unit itself, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 spurs off that badge telling me that the chain is grade 8. If you come across a link that's damaged, by simply inserting the point of the star into the link itself, it gives you an indicator of how or if the link is damaged anyway. Remember that chains are elastic, they will stretch, but they will come back into their normal formation when the weight comes off them. But if we shock load lifting gear, they stretch beyond the point and subsequently they'll never go back to their normal position again. Therefore, you can't or don't have that type of movement between the links themselves. Be careful of discolored chains and discoloring under that blue-purple thing where they're being heat damaged or where they've been exposed to excessive amounts of heat. If you're using chains against burning gear, heat can damage. Heat can travel into the lifting gear itself and cause the chain to heat up and subsequently force it to rapidly to cool down, weaken it. Be careful of welding with it and subsequently any sources of heat near the unit itself. Again, 40 degrees, below -40, we don't hit that temperatures. But I'm always telling that, especially with cranes, never leave chains hanging overnight. If we have chains hanging off a crane that are being exposed to the wind at high wind speeds, the hooks are hopping off each other and subsequently shock loading can occur. When it comes to lifting gear itself, and I suppose I'm so conscious of time because I could talk about this stuff all day. When it comes to the lifting gear, how you're storing it, how you're maintaining it, how you're looking after that piece of lifting gear, from the shackles, from the lifting eyes, all these elements, from the slings that you're using. And remember, there's a little pointer there for you. When it comes to slings, there's 4 ways of identifying the capacity, the tag, the color, the lines, and the width of the sling. If you're going through a lot of slings, look at the quarantine element. Have a look and see how they're being damaged, why they're being damaged. Trace it back a little. Look at your shackles, especially the excavators. Make sure they're not bent or twisted in any way, that when they go into that quick hitch, they're running through safely. And also make sure that you're storing it correctly and looking after it correctly itself. Okay? Thanks very much.
Thanks again, Michael. Yes, so really good information there on the equipment, and it goes to show the importance of maintaining the equipment properly. And I'm not sure how many slinger or signalers we have on the call today. Probably not a lot, but you know, for everybody here, it's really important to know how important it is that we have our trained slinger signalers, and they're the only people that should be on site managing slinging loads and managing their equipment properly on site as well. And it all goes to reducing accidents and incidents on our sites. Thanks again, Michael. I'm just going to touch now on our lifting operations golden rule. So this is one of 2 new golden rules. It's part of our minimum requirements document PR029. And I suppose these were developed to ensure consistency of how our critical risks are being managed on our sites. So I suppose the ask is, if you're not familiar with these, please go and have a look at our minimum requirements document PR029. It's all in there, and ensure that the procedures on your sites align with that, with the key controls. And those key controls in terms of the lifting operations are the lifting operations must be planned, assessed, appropriately supervised by competent personnel, and you would have seen that on the previous slides by Michael as well. And a lift plan must be in place for all mechanical lifts. And again, Michael mentioned that there, if it's suspended, you need a plan. This is not just about the big lifts. Okay, the big lifts take a little bit more planning, but if you're lifting a pipe, manual ring, or whatever it is, it needs to be planned. It needs to have the proper equipment and the proper trained personnel in place to do it safely. Ensure persons involved in lifting operations have the correct training. So again, you have the appointed person, as was mentioned, the lift supervisor, the slinger, who's a really important person, the crane operator and the plant operator, and they all have to have appropriate training in date, etc. Lifting equipment must be certified for use, so that's your GA1 form, must be inspected before use and recorded weekly, that's your GA2, and again, that all has to be kept on site, those forms for inspection, and defective equipment must not be used and must be reported immediately and taken away off site so it can't be used. There should be adequate means of communication, such as hand signals or two-way radios, etc. And again, make sure that they are properly charged in advance of any lift, etc. Next slide, please. And again, know the safe working load and never exceed it. So again, that's something that the person involved in the lifting operations need to know. So what's the capacity of your excavator? What's the capacity of your crane? And what's the capacity of all your slings and chains? Ensure a dry slew and a test lift is complete. So that's just a dry slew. It's just essentially where the machine or the crane is able to slew around to make sure it can do the full radius. And a test lift is completed. So again, when you do attach the lift it up to 6 inches off the ground, make sure everything's okay before you go ahead and lift it up in the air into its place. And that's to verify the radius and weights as per the plan, lift plan. Exclusion zones, really, really important. Make sure that they're in place prior to lifting or unloading commences. And again, that's to make sure that nobody enters that work zone. Loads should not be lifted over people or in the vicinity of overhead power lines. And again, there's a code of practice there from the ESB that we need to comply with if we are lifting in the vicinity of power lines, and make sure that that's in place as well. And tag or guidelines must be used to control or guide the loads where necessary. And again, for complex lifts, this is for the really big lifts, the appointed person must be satisfied that ground conditions have been properly assessed. So if there's poor ground there, the last thing you want to do is for the leg of a crane to start to sink into the ground when the load is mid-air. So again, that's really important that that's assessed by the appointed person. So I think that's a summary of it. We're just going to hand over to Kieran Hogan now, who's going to take us through any of the Q&As, please. Thanks, Kieran.
Great, thanks, Ewan. Yeah, there's just a couple of questions there come through the chat box. Directed to yourself, Michael. The first one is just around lifting of pipes and kind of relates back to the first video that you showed us. But is it acceptable in any circumstances to use just one sling when lifting pipes?
No, in answer to your question, and I know sometimes we do have to lift it to get them in and butt them up together, and really and truly it's a last choice you need to make, because you're relying massively on the balance of the load itself, and subsequently if you are going to be doing it, the precaution obviously is a double wrap on the sling and piece of lifting gear, making sure it's not crossed at the bottom, keeping it as low to the ground as possible, and then taking it into position. Obviously, it's always better to have those two direct revolutions of lifting gear on the pipe itself. Yeah. Okay.
Yeah. Thank you very much. And just the next one is just around non-return valves on excavators. Should excavators be fitted with non-return valves when used for lifting operations?
Yes, massively. Yeah. It's part of the requirements now, and they have to be fitted. Yeah. Sorry, that's Brian. Yeah.
And I suppose as an add-on to that then, what's the contractor's obligations there around inspections on non-return valves?
Brian, do you want to get that one?
Yeah, I suppose just as part of the GA1s, they would be checked as part of that, yeah.
Okay, very good. Just the other one is in relation to the register of lifting equipment. Maybe Brian, you can take this one. But how often is the register of lifting equipment on site to be kind of updated and reviewed on your sites? And I suppose ultimately who's responsible for its sign off?
Well, I suppose as any new equipment comes on site, you put it on the register. Any new slings are changed. I know that can be difficult on a large project, but it is important to maintain that and to check that on a weekly basis. And obviously have your visual check before you lift, but to record some form of a recorded check on a weekly basis.
Okay, very good. And then just another one, Michael, back over to you. Just around specific training required for excavator operators. So other than the CSCS training, what else is required for excavator drivers?
Your excavator, I mean, the two of us have kind of touched on it in respect of the program. The CSCS program really devotes its time to the excavating element of it, but it has limited information in respect to lifting and lifting operations that the excavator is used for. We know we use it on a lot of projects in the early stages. I suppose you have to go back to the competency of the personnel. You know, are they trained? Are they competent? And the training programs are there. The NPORS program is there. Excavators being used as lifting loads or lifting with suspended loads. You know, the training is there for guys. And the thing is, when we bring guys into the programs, they get a multitude of information. The feedback is massively positive in respect of the content that we deliver. So definitely the training is there for the guys. Murphy's have already rolled it out. A number of tier 1 contractors are rolling it out, where lads are using for clients for lifting. They have to be trained, and the NPORs or the programs are there for it. Yeah.
Okay, thank you very much. And just last question before we wrap it up. Someone has asked here, is a UK blue card for AP lifting valid in Ireland?
Yes, it is. Because we don't have any formal CSCS program for appointed person, lifting supervisor and advanced slinger signaller. One of the things that Proactive has done is we've got a Sitting and Guilds certification on it. So we've kind of got it up and down. But yes, in answer to your question, the blue card is acceptable, good card to have, and by all means, yeah, we accept it across the industry.
Great stuff. Yep, that's all the questions. If anybody else has any specific questions around lifting operations or anything else, feel free to email amisafe@water.ie. And I'll hand back over to you, Ewan.
Okay, thanks, Kieran. So look, that concludes our call. I just wanted to say a big thanks to Michael Norton and Brian Murray in particular, our external speakers. They're really good information, and we really appreciate your time coming on. And again, for everybody else, just please go and have a look at our minimum requirements document, PR 0 to 9, with our new golden rules in it. And again, any videos that you have, email them into amisafe@water.ie. There's some really good content up there on the AmiSafe website, and we're trying to get more and more videos up there. They're great in terms of sharing lessons learned and good catches and safety conversation starters as well. So with that, I will hand you back 5 minutes of your time, and hope you have a great Tuesday. Take care.
Okay, guys, that's everything now.
Yeah.
Okay, thanks a million, everyone. I think everyone's off the call, otherwise, just 1 second.
Yeah, there's 5 there, and yeah, we're good.
No, that went brilliant. Thanks for everyone getting involved there. We ended up on time anyway.
Yeah.
Thank God. I was
Yeah.
starting to panic a small bit.
That was grand. I was always going to put my time back anyway, Lisa, so fine. No panic.
Leave it out completely. I know it was brilliant, and
Really good.
there was a
Actually,
lot of information to jam
A lot
in
of
there.
information. Yeah, it was really good and great to have Michael and Brian there. So just
Yeah,
to get
really linked in, didn't it?
it was very good. Well done.
No, and thanks to yourselves, Kieran and Ewan and Rahul. You've been a massive help in getting it all together. So thanks a million for that. And look, we'll wait for the next one to get you roped into that one as well.
We're experts now, you know.
Experts in the field now.
I've
All right.
copied the questions and stuff, Lisa, so I'll send them on to you in a second.
Great. Thank you so much.
Great
And
stuff.
yeah, I'll talk to you soon. Thanks
Talk
a
soon.
million.
All right.
Cheers. See you.
Fair
Bye.
play,
Bye-bye.
guys.
Bye-bye.
Well done.
Bye-bye.
Cheers.
Bye.